So friends, let's now look at the advanced quiz on a number system. So here are some of the questions. So moving on to some more questions. We'll be looking at the solution for these now. So now let's look at the solution for question 1 in the advanced set. We need to find out all the prime numbers of the form n cube minus 1, where n is a natural number. Now we know that n cube minus 1 can be written as n minus 1 into n square plus n plus 1. Now for n cube minus 1 to be a prime number, it should only have 1 and itself as the factors. So this is possible only for n equal to 2. For any other value of n. So if we have n equal to 2, we know that n minus 1 becomes 1 and n square plus n plus 1 becomes 4 plus 2 plus 1, which is 7. So we get the number 7. For any other value of n, which is maybe 3 or any other number, so if we take 3, we get n minus 1 equal to 2. So that is one factor, and the other factor would be n square plus n plus 1, which would be another factor, and 1 and itself remaining the factor. This number is not a prime. That number will not be a prime number. So the only prime number of the type n cube minus 1 is 7. Now the second question, we need to find the units digit for 11 raised to power 5 multiplied by 12 raised to power 3 multiplied by 13 raised to power 4 multiplied by 14 raised to power 3 multiplied by 15 raised to power 1 multiplied by 16 raised to power 6. Now now we'll first do one thing, that we'll find out the units digit of each of them individually and then find their product. So units digit of 11 raised to power 5 is clearly 1. The units digit of 12 raised to power 3 is 8, because 2 raised to power 3, we know the units digit is 8. For the units digit of 13 raised to power 4, we know that 3 raised to power 4 is 81 and its units digit is 1. Looking for the units digit of 14 raised to power 3, we know that its units digit is 4. Units digit for 15 raised to power 1 is 5. And units digit for 16 raised to power 6 is 6. Now we take a product of all these units digit. We get 1 multiplied by 8 multiplied by 1 multiplied by 4 multiplied by 5 multiplied by 6. And that comes out to be 960, whose units digit is 0. So the units digit of this product being 0, we can say the units digit of the whole expression will be 0. Now let's look at the third question. It says that if HCF of x square minus x minus 6 and x square plus 9x plus 14 is x plus m, we need to find out the value of m. So we'll first factorize the first expression, x square minus x minus 6, and we get this to be equal to x minus 3 into x plus 2. Similarly, we factorize x square plus 9x plus 14 and we get x plus 5, x plus 7 into x plus 2. Right? So we clearly see that the common factor is x plus 2 in this. So we can say that HCF of these two expressions is x plus 2. And now comparing this with x plus m, we get m is equal to 2. Moving on to the next question. Two numbers which have HCF 29 and LCM as 4147, and both the numbers are greater than 29, we need to find out the numbers. So let's assume that the numbers are 29a and 29b, because their HCF is 29. The two numbers have to be multiples of 29. So we take them as 29A and 29B. We know that the LCM, the product of HCF and LCM is equal to the product of the two numbers, which give us 29A multiplied by 29B is equal to 29 into 4147. So this gives us 4147 is equal to 29AB, and hence AB is equal to 143. Now 143 has factors 1 and 143, and second set is 11 and 13. So these are the only possible factors of 143. Now, since it says that both the numbers have to be greater than 29, if we take 1 and 143 combination of A and B, so we get one of the numbers as 29 and the other would be definitely more than 29. So this option has to be ruled out. We take the other option, which is 11 and 13. So we get the possible values of A and B are 11 and 13, and the numbers will be 11 into 29, which is 319, and 13 into 29, which is 377. So these are the only possible numbers with the given HCF and LCM values and the numbers being greater than 29. Let's now look at the fifth question. We need to find the greatest 5-digit number which when divided by 4, 6 and 14 leaves 1, 3 and 11 respectively as remainder. Now we see that the difference between the number and the remainder is common, like 4 minus 1 is giving us 3, 6 minus 3 is giving us 3, and 14 minus 11 is giving us 3. So now we first find out the LCM of these three numbers, 4, 6 and 11, which comes out to be 84. Now greatest 5-digit number is 99999, and if that is divided by 84, it leaves 39 as the remainder, which we will subtract from this, and we get 99960, which is the greatest number divisible by these three given numbers, 4, 6 and 14. Now we need to find out the greatest 5-digit number which will leave the given remainders also. So we will subtract this common difference 3 from the number 99960, and we get 99957 as the greatest 5-digit number meeting the given criteria. Now moving on to the last question of the advanced level quiz. We need to find the number of positive integers n in this range where n lies between 12 and 40, such that the product n minus 1 into n minus 2 into n minus 3 till 1 is not divisible by n. Now we know that the prime numbers have only 1 in itself as their factors. All the non-prime numbers will have all its factors in the product. So say for example we have any number like 4. We are not taking n in this range right now. Just for an example, if we take 4 and we get this n minus 1 into n minus 2 into n minus 3, that becomes, we take n as 4, so it becomes 3 into 2 into 1. Now clearly 2, which is a factor of 4, appears in this product. So for any non-prime value of n, if we have to find out n minus 1 into n minus 2 into n minus 3 till 1, its factors will definitely appear in the product. So the product will be divisible by n. So that means the only possible values are only which are prime numbers between 12 and 40. So the prime numbers between 12 and 40 are 13, 17, 19, 23, 29, 31 and 37. So there are these 7 possible positive integers between the range 12 to 40, such that this product is not divisible by n. Friends, I hope you enjoyed the session. If you find it useful, please like it and share it with your friends. You can visit us at our Cool Smart Learning website and post your queries there. And please subscribe to the Cool Smart Learning channel for getting updates on the new sessions. Thank you.